So as we discussed in the last class about memory allocation, mainly it is of two types. First one is static memory allocation. Second one is dynamic memory allocation. So we are going to call it as fixed size allocation, and it is called as variable size allocation. And this fixed size is again divided into two types: fixed size of fixed equal sizes and different sizes. Meaning of equal sizes is the main memory is actually divided into blocks all of equal sizes. For example, the first block is 2K, second one is 2K, third one is 2K, and last one is also 2K. In the second case, different means that the first one is 2K, second one may be a different one, 4K, it may be 6K, it may be something else, maybe 8K, something like that. Okay. Now in both of the cases it is called as a static fixed size memory allocation with equal sizes, static fixed size memory allocation with the different size blocks. In both the cases we will have internal fragmentation as well as we have the external fragmentation. Now when talk about dynamic variable size, definitely on the top we are going to have OS. In the initial stage, initially everything is a whole in the sense everything is an empty space, but later in the due course they are occupied by processes and holes, and so on. Okay. So here, as already discussed, there is no internal fragmentation, but there is external fragmentation. Okay. So definitely this internal fragmentation and external fragmentation both are considered as problems. Luckily we don't have any internal fragmentation in dynamic variable size allocation, but we have external fragmentation. In order to remove this external fragmentation, we have few solutions. First one is compaction. What it says is, okay, if you have your main memory like this, process followed by a whole, process followed by a whole, okay, and one more process. This is the current situation of your main memory. Because of compaction, what happens is all holes will come to one place and all processes will come to one place. So all holes, all processes. When we combine all the holes together, we get empty space which is very large, so that it can accommodate any new incoming process easily. So the solution is called as a compaction. But there is one disadvantage with this compaction. The disadvantage is, okay, so if you are trying to convert this memory status into this memory status, here we need to perform an operation called copying. So this process has to be copied into this place. Before that, this has to be copied to some other place. Okay, so you can observe here, we need a process of copying. We need an operation of copying. So that copying will actually take some time. So all this time, your CPU will remain idle. Okay, so this is going to be one of the disadvantage in the compaction. So we got to we want to enter or discuss another solution called non-contiguous allocation. So what it says is, it is opposite to the contiguous allocation. Whenever for example, if we have some memory like this, we have a hole here, we have a process here, again we have a hole here. This is of 1 kb and this is of 1 kb and this is of, for example, 2 kb. Now if there comes a process whose size is 2 kb, now is it possible to store this 2 kb process in these two holes, in any one of these holes? Definitely not. Reason is, it is only 1 kb, the size of the process is 2 kb. So definitely, according to our rule, our process must be continuously stored, mean sequentially it has to be stored, all this 2 kb. But now if you break that rule, it is called as non-contiguous allocation. That means you are going to divide your process into two parts. First part you are going to store here in a hole, the second part you are going to store here. If you use this solution, that is called as a non-contiguous allocation. So generally there are two methods which follow this non-contiguous allocation. First one is segmentation, second one is paging. Now we will discuss segmentation, and next we will discuss about paging. Remember, paging is very important, and we also have lab programs on this paging.